today we're going to talk about special products, or they're the special products, so they're kind of shortcuts in math. So if you think back to what we did yesterday, we were multiplying our binomials times binomials and binomials times trinomials. Okay, we had maybe x plus 2 times x minus 3, and we multiplied it out to get our x squared, our negative 3x, our positive 2x, and our negative 6.
Yeah.
Okay, so it takes a while, but we get there, and you for sure could go through that process each time. So anything I teach you today, you could always revert back to what we already know. I am trying to show you shortcuts today. Okay, shortcuts, they're quick ways of finding the answer without having to go through that whole process. So there are a couple patterns that we look at. First is called the square of a binomial pattern. Okay? What that says is if I have a number, and we'll call that number A, and I have another number, we'll call it B, and we are adding those up and squaring them, the answer will be in the form of whatever this is, squared, and the back will have whatever that number is, squared, and the middle will be just those two multiplied together and doubled. Okay, so for instance, if I have this, my first term is x. Okay, well this says you take your first term and you do what to it? Square it. So the answer is going to be x squared. This here says you take the back one and square it. So at the back you're going to have plus 2 times 2, which is 4. And this middle thing says I have a times b times 2, or AB doubled. So if I take that and that, what do I get when I multiply them? 2x, and I double it, I get 4x. That is the answer to that. Okay, it's a shortcut. Now, if you can't remember the shortcut, please remember at least that this little squared right here means I am taking this and I'm multiplying it by that. All right, so really, if you can't remember the shortcut, then you could just revert back to doing it this way.
It's not that hard. It's just time.
Okay, but note, there's where your front term squared comes from. There's where your back term squared comes from. And then look, you have 2 of those. That's why you multiply them together and double it. You can go through that same process if you forget. All right? I'd like you to try the patterns, though. So I want you to try that on letter B. Try to do it using the pattern that we just discussed. Oh, hold on. Letter B is actually a -1. We'll take a look at the -1, see if you can apply this pattern to that. Very similar. Just you have that subtraction in the middle.
Okay.
Oh, we'll check.
I
You forgot one piece.
I did square the 1, but I believe anything. 1 times anything is.
Do the middle. Okay, so how many of you match up with what your neighbor got? What's that? I didn't hear. Okay. No, talk to them. Talk to them. Talk to the guys behind you. Okay, let's see. The front term is what? A squared, which is? That's our A term. 4x squared. Okay, so you got to square the 4 or the 2 and the x. The back term is b squared. Here's our b term. B squared is? -1 and -1 is? +1. And then we multiply them together. 2x doubled. And it's minus, right? It's a -2x doubled. So we get a minus.
Yeah, I think I'm more comfortable doing the original.
Hey, you're going to be more comfortable doing it the long way because you've more practice with it. What I'm telling you is that if you could learn the shortcuts, it saves you time. Okay? How many got it? A couple. Good. Okay. Questions? All right. Hey, the next one's, I've never I've never heard it referenced as the sum and difference product or pattern, but usually you'll hear it as difference of two perfect squares.
It doesn't make sense because you distribute everything in the first parenthesis set, right?
Difference of two perfect squares.
So you get a squared b.
Okay, let's give me a minute here. Yeah. All right. So when you're going through this, if you have a plus b and a minus b, so note the similarities and note the differences. One has a plus, one has that minus. It says that if I were to multiply this out, I'd end up with a squared, whatever that term is, or that term, squared, minus b squared. There's our perfect square, there's our perfect square, and that's the difference. That's why we call it the difference of two perfect squares. Okay? And so, let's check that out. If I do this one, go ahead and write what your answer would be. Try to do it the shortcut way. Read this without actually multiplying by hand. Use the pattern there. All right, what's a squared? What is a? X, okay? So a squared would be x squared. What's b? Yeah, in this case b is 2, so we get minus 4. That's our answer. Nice little pattern. Okay? So for those of you who are like, how does that work? Why does that work? Think of it like this. If we were to actually multiply it out the long way, you would get x squared. You would get your negative 2x. But to cancel that negative 2x, you end up with a positive 2x right there. Okay? And then there's your negative 4. So the middle part cancels because you get a negative and a positive. You're left with x squared minus 4. That will always happen. That's why we want to learn the shortcut. It's just quicker. Tell your neighbor what this one would be.
For x squared. No, I'm just trying to figure out what the last one would be.
What's your b term?
1. Negative 1.
For x squared minus 1?
Oh, right.
How many got? That's it. Very good. Any questions? Cool, man. Your assignment is the back page. Okay, page 217, which is the next page of the packet, and the page without a number. Sorry. Numberless page. You can number it whatever you want. There you go. All right?
On number
Go.
3,333.